Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 18, Tangents and Intersecting Chords. We'll be discussing some theorems with examples and solve many questions from exercise 18B. Hope you have watched my previous video where we have started this chapter and discussed some theorems there. If you haven't watched, go watch it first, then come back to this video. Next theorem, the angle between a tangent and a chord through the point of contact is equal to an angle in the alternate segment. Here, what is a tangent? You know what a tangent is? A tangent is a line that touches the circle at only a single point. And what is a chord? Here, when you consider this circle, I am drawing a tangent for the circle. This is my tangent PQ. PQ touches the circle at point A. Now I am taking a chord. This is my required chord AB. Okay. Starting from A till B. Okay. A and B lies on the circumference of circle. When I am taking this tangent and the chord, there is an angle formed between them. Okay. Here, according to the statement, the angle between a tangent and a chord through the point of contact, this A is a point of contact, is equal to an angle in the alternate segment. What is alternate segment? When you take this chord AB, AB divides the circle into two. Okay, this is a smaller segment or the minor segment and this is my major segment. Okay, now the angle, required angle, which is the angle formed between the tangent and chord, lies in the minor segment in this case. Okay, then we have the other segment. This other segment is called the alternate segment, the segment in which this angle, that is angle formed between tangent and chord, is not included. So, in this alternate segment, I am considering some point on the circumference of circle which I denote by C. Okay, from C I am drawing straight lines. This is CA and this is CB, that is to the ends of the chord. I am drawing straight lines. So here an angle is formed. ACB is an angle. What is ACB? ACB is the angle subtended by the chord AB on the circumference of circle. So according to this statement, according to this theorem, it is said that the angle formed between the tangent and chord at the point of contact is equal to the angle formed by the same chord in the alternate segment. So here in the alternate segment, the angle formed is ACB. Okay. According to this, we will be having ACB is equal to angle QAB. Okay, QAB. Here we had the smaller angle in the minor segment and this smaller angle is equal to this angle, which is the angle formed in the alternate segment. Okay, we have a small angle, that is an angle that is smaller than the 90 degrees. Now I am taking another circle. Again, we'll consider the tangent PQ, point of contact A. We have the chord AB. Now, here we have a bigger angle. Here in this case, we consider the smaller angle, that is the angle formed between the tangent and chord. Again, this is also an angle that is formed between tangent and chord. Here we have tangent and this is our required chord. This is an angle which is greater than 90 degree. Now we have taken this bigger angle. Where does the alternate segment angle be? Now this is a bigger segment. We have the angle formed between the tangent and chord in the bigger segment. Okay. Now which is the alternate segment? This minor segment or the smaller one is the alternate segment. In the alternate segment, I am considering a point C. Okay. Same case we have done previous. From A and B, we will be drawing straight lines to C. So this is the subtended angle. Angle subtended by chord AB in the alternate segment. Here again we will be having angle ACB is equal to PAB. This bigger angle. Here when you look at this figure, it is clear that this angle and this angle are bigger angles and these two are smaller angles. Okay, so what is the statement? The angle between a tangent and a chord through the point of contact is equal to an angle in the alternate segment. We have discussed both the cases, that is a smaller angle formed between the tangent and chord, and also the bigger angle formed between the tangent and chord. Understood this theorem? Let's move on to the last theorem for this day. The statement is, if a chord and a tangent intersect externally, then the product of the length of the segments of the chord is equal to the square of the length of the tangent from the point of contact to the point of intersection. Here we have the circle. Okay, in the circle, TP is the tangent, AB is the chord. Okay, from this AB, from the chord AB, we are extending AB to a point P, such that the tangent intersects chord extended at point P. Okay, so this P is point of intersection, and this T is the point where tangent touches the circle. So T is the point of contact. Now, according to the statement, we have AB extended to P. Two segments are there, that is segments of chord. Length of the segments of chord are AP and BP. When you take the product of AP and BP, that is product of the length of the segments of the chord. Segments of chord are AP and BP. Product of it, that is AP into BP, will be equal to the square of the length of tangent from the point of contact to the point of intersection. So here TP is the length of the tangent from point of contact T to the point of intersection P. Therefore TP, just not TP but TP square. So according to this theorem, we will be having AP into BP is equal to TP square. You don't have to study the proof, just understand this. Here we have a circle, AB is the required chord, TP is tangent, AB when extended meets TP at point P. Okay, then P is point of intersection and T is the point of contact. When you take the product of the length of segments of the chord, you will be getting it equal to the square of the length of tangent from the point of contact to the point of intersection. Clear? So this is our third theorem. Let us do some examples. Here we have the first example. From each of the following figures, find the value of x. So here we have the first figure. In this figure, we have chords AB and CD which intersects internally at point P. Okay. So given that PA is equal to 4 cm, PB is equal to 6 cm, PC is equal to 5 cm, and we need to find PD, that is x centimeter. We need to find the value of x. How to find x? According to theorem, we have PA into PB is equal to PC into PD. What was the theorem? We have studied the theorem. That is, when two chords meets internally or externally, then the product of the length of the segments of the chord will be equal. Okay. Therefore, PA into PB. PA is one and PB is the second part of the chord. The products when taken, it will be equal to PC of the other chord and PD of the other chord. Okay. Product. Now just put the values. We have PA. PA is 4. PB is 6. PC is also given 5. And PD is X. Okay, then what is x? X will be equal to 4 into 6 divided by 5. 4 into 6 divided by 5. 4 into 6 is 24 divided by 5. What is the value? 24 by 5 will be getting 4.8 centimeters. Okay, so here the value of x is 4.8 centimeter. First question. Now the second one. Here again, we have two chords which intersects internally at point P. AB is the first chord and CD is the other chord. Given that PA is equal to 2 times PB is equal to 12 centimeter, from which we can find the value of PA and PB. PA will be equal to 12 centimeter. 2 times PB is equal to 12 centimeter, which implies PB is equal to 12 centimeter divided by 2, and that is 6 centimeter. We got PA and PB. Then PC and PD both are equal to x centimeter. PC, here we have PC and this is PD. Okay. So according to the theorem, we'll be having PA into PB is equal to PC into PD. Put the values. PA is 12 into PB is 6 is equal to PC is X and PD is also X. 12 into 6 will be getting 72 equal to X square and X is equal to root of 72. How to find the root of 72? 72 can be divided with 2. We'll be getting 36. 36 again dividing by 2. We get 18. 18 by 2 is 9. 9 divided by 3. We get 3. 3 by 3, 1. Okay. Now pairing. 2 and 2 can be paired. We get a 2. 3 and 3 pairing. 3. Okay. 2 into 3 is 6 and we have a 2 alone. Therefore, this is 6 root 2. Okay. So, the root of 72 is 6 root 2. 6 root 2 centimeters. Clear? Now, the third figure. This is our third figure. Here we have AB is equal to. AB is 10 centimeter. PB is given. PB is 6 centimeter. CD is equal to X centimeter. And PD is equal to 4 centimeter. PD is 4 centimeter. We have to find the value of X. Here again we will be having PA into PB is equal to PC into PD according to the theorem. Now we don't know what PA is. How to find PA? PA will be equal to AB plus PB. Okay. What is AB? AB is given, that is 10 centimeter plus PB. PB is 6 centimeter. PA is equal to 10 plus 6 which is 16 centimeter. Okay. PA is equal to 16 centimeter. Okay. Now PC. PC also we don't know. We can find PC. PC will be equal to CD plus PD. PC is equal to. What is CD? CD is X plus PD. PD is 4. Therefore, PC is equal to X plus 4. Now putting the values. PA 16 into PB. PB is 6 is equal to PC is X plus 4 into PD. PD is 4. We'll find the value of X. X plus 4 is equal to 16 into 6 divided by 4. 4 and 16 can be cancelled. 4 into 4 is 16. That is 4 into 6, 24. If X plus 4 is equal to 24, X plus 4 is equal to 24, then X is equal to 24 minus 4. Taking this plus 4 to the opposite side, it becomes minus 4 and that is equal to 20 centimeter. X is equal to 20 centimeter. Now the fourth figure, considering the fourth figure, here we have chord BC and the tangent AP. When this BC chord is extended, the tangent and the chord extended meets at a point P. In that case, we'll be having the length of tangent square AP square will be equal to the product of the segments of the chord. That is PB into BC. Here what are the quantities given? We have PA or AP is equal to 20 centimeter. PB is given which is 60 centimeter and BC is X centimeter. Putting the values, PA that is AP 20 square is equal to 16 into X. Okay. 16 into X is equal to 20 square is 20 into 20. Then X is equal to 20 into 20 divided by 16. Okay. 4 4s are 16. 4 5s are 20. Again 4 into 1 is 4. 4 into 5 is 20. Therefore, X is equal to 25 centimeter. Here the theorem used is the length of the tangent from the point of intersection to the point of contact is equal to the product of the length of chords of the segment. Next example, ABC is an isosceles triangle with AB is equal to AC. A circle through B touches side AC at its middle point D and intersects side AB in point P. Show that AB is equal to 4 times AP. Here we have a triangle ABC. ABC is an isosceles triangle given that AB is equal to AC. Okay. Now, a circle through B. B is a vertex of triangle ABC. So, a circle that touches B will be touching the side AC at the middle point D, which means AD and CD are of equal length and AD will be equal to half of AC. Okay. Also, we have point D and it intersects side AB. Intersects side AB. AB is this side. The circle intersects AB at point P. So, this is a point P. We have to show that AB is equal to 4 times AP. So, here to prove AB is equal to 4 times AP. Now, we have AD. AD is equal to half of AC. Okay, since D is the midpoint, we'll be having AD is equal to half of AC. If AD is equal to half of AC, then we can write AD is equal to half of AB because we have AB is equal to AC. AB and AC are of equal length in the isosceles triangle. AD is equal to half of AB. Then what is AD square? AD square will be equal to half of AB whole square, which is 1 by 4 AB square. 1 by 4 AB square. Okay, AD square is equal to 1 by 4 AB square. Now consider this chord BP. BP is extended to a point A and the tangent, here we have AD. That is, the tangent and the chord when extended intersects at point A. So, according to theorem, we will be having AD square is equal to AP into AB. Okay, that is the product of the length of segment will be equal to the square of the length of tangent from the point of intersection to the point of contact. Okay, now what is AD square? We have AD square is equal to 1 by 4 AB square and that is AP into AB. Here from right hand side and left hand side we can cancel 1 AB. AB into 1 by 4 is equal to AP, which means AB is equal to, taking this 4 to the opposite side, here it is division, it becomes multiplication. 4 into AP. So this is the required proof. Hence proved. Okay, we are using the theorem to do this. Clear? Let us now solve some problems from exercise 18B. Here we have the first problem, question 1, sub-question 1 of exercise 18B. In the given figure, 3 into CP is equal to PD is equal to 9 cm and AP is equal to 4.5 cm. Find BP. Here we have a figure. AB is one chord and CD is another chord which is intersecting at point P. Now, from the given, we can have that is 3 into CP is equal to PD equal to 9 cm, which means 3 into CP is also equal to 9 cm. Then what is CP? CP will be equal to 9 cm divided by 3 and that is equal to 3 cm. Okay, CP is 3 cm. This is CP and CP we have 3 cm. Then we have PD given. PD is equal to 9 cm. This is PD and PD is 9 cm. What else? Here we have the value AP. AP is this part and that is 4.5 cm. We have to find BP. We have to find this length. Okay. We have a theorem. When two chords intersect internally or externally, then the product of their segments will be equal. Here what is the product of segments? We will be having AP into BP is equal to CP into dp. Okay, why? According to the theorem we have, when two chords intersect internally or externally, the product of their segments will be equal. Okay. So never forget to write the theorem. It carries some mark. So you have to have a clear idea about the correct statement of theorem, and you have to include the theorem as well. So we have AP into BP equal to CP into DP. Now put the values. What is AP? AP is 4.5 centimeter. 4.5 into BP. BP we have to find. BP is equal to CP is 3 and DP. DP is 9 centimeter. Then what is BP? BP will be equal to 3 into 9 divided by, taking this 4.5 to the opposite side, multiplication becomes division. 4.5, that is equal to, here 4.5 into 2 is 9, or you can do multiply the numerator and denominator with 10 in order to remove the decimal. Into 10 divided by 4.5 into 10 is 45. 9 5s are 45. 5 into 2 is 10. Then we have 3 into 2 and that is equal to 6. Therefore, BP is equal to 6 centimeter. The required length BP is 6 centimeter. Clear? We are just using the theorem and putting the values. You will be getting the length BP. Okay. Here the chords are intersecting internally, not externally. Chords are intersecting internally. Clear? Second part of this question. In the given figure, 5 into PA is equal to 3 into AB is equal to 30 centimeter and PC is equal to 4 centimeter. We have to find CD. Okay, here we have the figure. A point P is given. The chords are AB and CD. So AB and CD chords, when produced, they are intersecting at point P. Okay. Then what are the segments? Here we will be having AP, BP, CP and DP. Now it is given that 5 into PA is equal to 30 centimeter. 5 into PA is equal to 3 into AB is equal to 30 centimeter. Which means 5 into PA is equal to 30 centimeter. Then what is PA? PA will be 30 divided by 5 and that is equal to 6 centimeter. PA, this length is 6 centimeter. Okay. Then we have 3 into AB is also 30 centimeter. 3 into AB is equal to 30 centimeter, which means AB is equal to 30 divided by 3 and that is 10 centimeter. AB is this part, that is the length of chord. Length of chord is 10 centimeter. Next, it is given that PC is 4 centimeter. PC is equal to 4 centimeter. Where do we have PC? PC is this part and that is 4 centimeter. So according to the theorem, that is when two chords intersect internally or externally, the product of the length of segments will be equal. So using that theorem, we will be having PA into PB is equal to PC into PD. Okay. Here we know the value of PA and we know AB. Okay, we need to find PB, right? We know PA, we know AB. Then what is PB? PB will be equal to PA plus AB and that is 6 centimeter plus 10 centimeter which is equal to 16 centimeter. This whole length, this total length is 16 centimeter. Length PB is 16 centimeter. What we have to find? We have to find CD. Okay. So according to the theorem, we'll be having PA into PB is equal to PC into PD. That is theorem. Put the statement here. When two chords intersect internally or externally, the product of length of segments will be equal. Okay, now put the values. What is PA? PA is 6 into PB. PB we have determined, which is 16 centimeter, is equal to PC is given, that is 4 centimeter, into we can find PD. Then what is PD? PD will be equal to 6 into 16 divided by 4. Cancelling, 4 into 4 is 16. 6 into 4. 24 centimeter. So we are getting PD, that is this whole length is equal to 24 centimeter. Now we can find what CD is. CD will be equal to, we have PC plus CD is equal to PD. Then CD will be equal to total length PD minus this part PC. PD minus PC. Put the values. PD is 24 and PC is 4. 24 minus 4, which is 20 centimeter. Okay, so we are getting CD. This length is 20 centimeter. Clear? So here the product of segment we are taking PA into PB, PC into PD. Just remember this thing and put the statement of the theorem. Okay, third part, in the given figure, tangent TP is equal to 12.5 centimeter and PA is equal to 10 centimeters. PT is this part and that is 12.5 centimeter, and PA, this part is 10 centimeter. We have to find AB, this length. Okay. Here we have PT given. PT is equal to 12.5 centimeter. PA is equal to 10 centimeter. To find AB. Now AB is a chord of the circle. AB when produced, here we have a point P and this P. Here PT is a tangent to the circle. So from this point of contact, we have a line to the intersection with the chord which is externally extended. Okay, so that point is P. Now we have a theorem, when a chord and a tangent intersect externally, then the product of the length of the segments of the chord will be equal to square the length of the tangent from the point of contact to the point of intersection. Okay, we are using this theorem here. PT is the length of tangent from the point of contact to the point of intersection of chord and tangent, and therefore the square of PT will be equal to the product of the length of segments of the chord. Here the length of segments. Here we have first segment PA and the second segment PB. Okay, it will be equal to PA into PB. Clear? From this we can find PB. Now what is the reason? You have to include the theorem here. If a chord and tangent intersect externally, then the product of length of segments of chord is equal to the square of length of tangent from point of contact to the point of intersection. Okay, so you have to include this theorem as well. Now we have PT square. Put the values. What is PT? PT is 12.5 square is equal to PA is 10 into PB. PB we don't know, we can find PB. Then what is PB? PB will be equal to 12.5 square is 12.5 into 12.5 divided by this 10 taken to the opposite side, divided by 10. Now in order to remove the decimal, I am multiplying the numerator with 100. Also we have to multiply the denominator with 100. Therefore, we will be having 125 into 125 divided by, here already we have a 10 into 100. Okay. So 125 and 100 can be cancelled. 125. 25 into 5 is 125. 25 into 4 is 100. Okay. Then this 5 and 10 can be cancelled. We'll be getting 2. That is 125 divided by 2 into 4 is 8. So 125 divided by 8. When you do, you will be getting PB is equal to 15.625. Okay. 15.625 is the length PB. Length of the segment PB. What we have to find? We have to find AB. AB will be equal to the total length PB minus this part which is PA. PB minus PA. 15.625 minus PA. PA is equal to 10. And that is equal to 5.625. The required length AB is equal to 5.625. Okay. Here we have used another theorem. So remember this theorem, the statement of the theorem. If a chord and a tangent intersect externally, then the product of length of segments of chord is equal to the square of length of tangent from point of contact to the point of intersection. Okay. Next, problem number 2, question 3 of exercise 18B. In the following figure, PQ is the tangent to the circle at A, DB is the diameter and O is the center of the circle. If angle ADB is equal to 30 degree and CBD is equal to 60 degree, we have to calculate first one QAB, second PAD and CDB. QAB is this angle. So first we have to find QAB. We have studied theorems. Yes. Now when you consider this chord AB, AB subtends angle ADB on the circumference of circle and the angle made between this tangent and chord is the required angle QAB. So according to a theorem, we had the angle between tangent and the chord at the point of contact will be equal to the angle subtended by the same chord in the alternate segment. Okay, angles in the alternate segment. Therefore, the angle QAB will be equal to angle ADB. Okay, what is the reason? Angles in alternate segments. Here we are taking the chord AB with respect to AB. What is the value of QAB then? Since ADB is equal to 30 degree, QAB is also equal to 30 degree. So we got the angle QAB and that is 30 degrees. Now the second one, we have to find PAD. Where do we have PAD? PAD. This angle. How to find PAD? When you consider this chord AD with respect to AD, here PAD is an angle made between the tangent and the chord at the point of contact A. Now, the same chord makes an angle on the circumference of circle. Where do we have that angle? This angle ABD. This angle is made by the same chord on the circumference of circle. If we are able to find the measure ABD, it will be equal to PAD. Yes, so we will find ABD first. How to find ABD? Now when you consider this triangle, here we have 30 degree. What about this angle? DAB. DAB will be a right angle. What is the reason? This DB is the diameter and DAB is angle subtended by the diameter or angle in semicircle. We have angle DAB is equal to 90 degree. Reason? Angle in semicircle. Angle in semicircle. Now consider triangle DAB. We have ADB is equal to 30 degree. Angle DAB is equal to 90 degree. Now ADB plus DAB plus ABD will be equal to 180 degree. What is the reason? Sum of interior angles of a triangle is sum of interior angles of a triangle is 180 degrees. Okay. Now ADB is 30 degree, DAB is 90 degree plus ABD, which we have to find, is equal to 180 degree. Then what is ABD? ABD will be equal to 180 degree minus. Here 30 plus 90 we get 120. Taking 120 to the opposite side, 180 degree minus 120 degree, and that is equal to 60 degree. So we got ABD. This angle is 60 degrees. Okay. We have angle PAD equal to angle ABD, which will be 60 degrees. What is the reason? Angles in the same segment. Angles in the same segment. Angles in the same segment. Next, the third part, we have to find angle CDB. Where do we have CDB? CDB. This one. How to find CDB? This is very easy. We already know DBC. Then this angle will be 90 degree. What is the reason? Again, this is diameter. DB is diameter. And DCB is an angle that is subtended by diameter on the circumference of circle or the angle in a semicircle. We have consider triangle DCB, angle DBC is equal to 60 degree, angle DCB is equal to 90 degree, reason angle in semicircle. So wherever required you have to put the reason. Never forget angle in semicircle. Then we can find CDB. CDB, that is angle DBC plus angle DCB plus angle CDB is equal to 180 degrees. Put the values. DBC is 60 degree plus DCB is 90 degree plus CDB is equal to 180 degrees. Then CDB equal to 180 degree minus 60 plus 90 is 150. Taking 150 to the opposite side. 150 degrees, and that is equal to 30 degrees. Okay. CDB angle is 30 degrees. So we have determined all the required 3 angles. Clear? Problem number 3. Question 4 of exercise 18B. If PQ is a tangent to the circle at R, calculate PRS, angle PRS. Where do we have PRS? This is the figure, and this angle is angle PRS. Also, we need to find angle ROT. ROT, this angle. First, let us find PRS. What is given in the question? It is given that O is the center of the circle and the angle TRQ is equal to 30 degree. TRQ. This angle is 30 degree. If TRQ is 30 degree, I can say that angle RST is also equal to 30 degree. What is the reason? When you consider the chord RT, RT makes angle 30 degree with the tangent and RT subtends angle 30 degree with the circumference of circle. Okay, so we have studied that angles in the alternate segment are equal. Therefore, we have angle RST is equal to angle TRQ equal to 30 degrees. Okay, what do we need to find? We need to find first PRS. Okay, here this angle is 90 degree. Yes, angle SRT is equal to 90 degree. What is the reason? Here ST is the diameter of the circle. When you have the diameter, angle subtended by the diameter or angle in semicircle will be equal to 90 degrees. Therefore, angle SRT is 90 degree. Angle in a semicircle. Then, we can easily find what RTS is. Yes, What is RTS? Here when you consider the triangle RST, consider triangle RST, we have RST is equal to 30 degree and SRT equal to 90 degree. Angle RST plus angle SRT plus angle RTS is equal to 180 degrees. Okay. What is the reason? Sum of interior angles of a triangle is 180 degree. Okay. Now put the values RST. RST is equal to 30 degree plus SRT. SRT is 90 degree plus RTS. RTS we need to find angle RTS is equal to 180 degree. 30 plus 90 we get 120 degree plus RTS is equal to 180 degree. Therefore RTS is equal to 180 degree minus 120 degree. What is 180 minus 120? We get 60 degrees. Okay, 60 degrees. Angle RTS. This one is 60 degree. Okay. When you take the chord RS, the angle between the tangent and chord RS, this angle, and the angle subtended by the chord on the circumference of circle, that is RTS, will be equal. Therefore, angle PRS is equal to angle RTS, and that is equal to 60 degree. What is the reason? Angles in the same segment. Angles in the alternate segment. Okay, so we got PRS. This angle is 60 degree. Now the second one we have to find angle ROT. Okay, to find ROT, it is very easy. We have to consider the small triangle ROT. In triangle ROT, we have RO is equal to TO. What is the reason? O is the center of circle. Therefore, RO and TO are the respective radius. Okay, radii of circle. We know that radius of a circle are always equal. Since RO and TO are equal, angles opposite to equal sides should be equal. Here we have angle opposite to RO, that is RTO is equal to 60 degree. Then what is TRO? This angle also will be equal to 60 degrees. Okay, that is angle opposite to RO. We have angle RTO equal to angle TRO, that is 60 degree. Reason? Angles opposite to equal sides are equal. Okay, so we got this angle. If this is 60 degree and this is 60 degree, we can easily find what ROT is. We have angle RTO plus angle TRO plus angle ROT equal to 180 degree. Reason? Sum of interior angles of a triangle will be equal to 180 degrees. Okay. Now put the values RTO. RTO is 60 degree plus TRO is also equal to 60 degree plus angle ROT equal to 180 degree. 60 plus 60 we get 120 degrees. Then ROT will be equal to 180 degree minus 120 degree, and that is equal to 60 degrees. Okay, that is this angle is 60 degree. We get an equilateral triangle. All the angles are 60 degrees. Here we have determined the angles PRS and ROT. Problem 4, question 6 of exercise 18B. Tangent at P to the circumcircle of triangle PQR is drawn. If this tangent is parallel to side QR, show that triangle PQR is isosceles. So we have taking a triangle PQR. Now this is the circumcircle. The circle which touches all the vertices of the triangle. And we have a tangent which passes through the point P of the circle. Okay. It is given that the tangent should be parallel to the side QR of the triangle. Here we have tangent parallel to QR. Okay. We have to prove this PQR triangle is an isosceles triangle. What are the peculiarities of isosceles triangle? What are isosceles triangle? For an isosceles triangle, you will be having two sides equal or two angles of equal measure. Length of two sides should be equal or the measurement of angle, two angles should be equal. Okay. So here, if I am getting PQR is equal to PRQ, then my triangle will be an isosceles triangle. So here we have parallel lines. Okay. For a parallel lines, when transversal cuts, we will be having alternate interior angles equal, corresponding angles equal. Okay. Here, this is my tangent and this is the side QR of triangle. This angle and this angle will be equal. Okay. Here, let us take this tangent as some AB. Therefore, angle BPR. Angle BPR is equal to angle QRP. What is the reason? Alternate interior angles. Alternate interior angles. Okay. Now, when you take this chord PR, PR is a chord of the circle. Yes. When you take this chord, between this chord and tangent, an angle is made which is BPR. Okay. The same chord on the other segment, on the alternate segment, subtends an angle PQR. Okay. Therefore, BPR, angle BPR will be equal to angle PQR. That is angles in alternate segments. Okay. Here, this is my first equation and this is my second equation. When I compare, I am having the left hand side equal, therefore right hand side should also be equal. That is QRP, angle QRP will be equal to angle PQR. Okay. QRP, PQR. These two angles are equal. These two are the angles of same triangle. Since we get two angles equal, it is an isosceles triangle. Or you can take like PR is a side that is opposite to angle PQR. Therefore, PR will be equal to QPR. Q opposite to QRP. QRP, we have side PQ. And PQ will be equal to opposite to PQR. PQR, we have side PR. They are of equal length. Okay. So, if in a triangle, two sides are of equal length or angles are of equal measure, two angles are of equal measure, then it is an isosceles triangle. Therefore, triangle PQR is an isosceles triangle. Clear? So here, just consider the parallel lines. Take the transversal. Here PR is a transversal. So when a transversal cuts parallel lines, you will be having alternate interior angles. Then we are using the angles in alternate segment concepts to show that triangle PQR is an isosceles triangle. Problem 5, question 10 of exercise 18B. In the figure, ABCD is a cyclic quadrilateral with BC is equal to CD. TC is tangent to the circle at point C and BC is produced to point G. If angle BCG is equal to 108 degrees and O is the center of the circle, find BCT. Where do we have BCT? This angle BCT, and we have to find angle DOC. DOC. Okay. Now, here we have given. What are the given conditions? We have BC equal to CD. BC equal to CD. This is BC and this is CD. They are equal. TC is the tangent. This is the tangent TC. Point of contact is C. Okay. When DC. DC is a chord when DC is produced to a point G, and we have O as the center of the circle. Also we have angle BCG is equal to 108 degrees. BCG. This whole angle is 108 degrees. Okay. Now what I am doing is I will be joining these points B and D. Okay. Here we are getting a triangle. Now this angle BCG is an exterior angle to this triangle. We have studied exterior angle is equal to sum of interior opposite angles. Interior opposite angles are this one and this one. Okay. That is DBC and BDC are the interior opposite angles. Let's take them as some X. Okay. Since both these sides are equal, angles opposite to them should also be equal. Since BC is equal to CD, we'll be having angle opposite to BC, that is BDC. Angle BDC equal to angle DBC, that is angle opposite to side DC. DBC. Angles opposite to equal sides are equal. Okay. Angles opposite to equal sides are equal. Here, now take this triangle. You will be having sum of interior opposite angles, that is X plus X. X plus X equal to exterior angle. Exterior angle is 108. 108 degrees. What is the reason? Exterior angle is equal to sum of interior opposite angles. So here we are considering the triangle BDC. In triangle BDC. Okay. That is X plus X we get 2x. 2x is equal to 108 degrees. Then what is the value of x? X is equal to 108 degree divided by 2, and that is 54 degrees. Okay, we got x is equal to 54 degrees, which means angle BDC is equal to angle DBC, and that is 54 degree. What we need to find? We need to find BCT. BCT. This angle we have to find. Is there any relation between BCT and BDC? Okay. Here, considering the chord BC and tangent CT makes an angle BCT. The same chord on the circumference of circle makes an angle BDC. Okay. So they will be equal. Angle BDC is equal to angle BCT. What is the reason? Angles in the alternate segment. Angles in the alternate segment. That is, you are considering the chord BC here. Okay. Here when you take this segment, this is the alternate segment. Now we got BDC is equal to BCT. Then what is the value of BCT? BCT is equal to 54 degrees. BCT. This is 54 degrees. Okay, clear? Now the second one we have to find DOC. To find DOC, I am joining this center point O and D. Similarly, O and C. Then we will be getting the angle DOC. Now how to find DOC? We have angle DOC equal to 2 times angle DBC. In the previous chapter we have studied this. Why? When you consider this chord or this arc DC, DC subtends angle DOC at the center and DBC on the circumference of circle. We have angle subtended by a chord at the center is twice the angle subtended by the same chord on the circumference of circle. Angle subtended at the center is twice the angle subtended on the circumference of circle. On the circumference of circle. Okay. So we need DOC. What is DBC? DBC we have already determined, that is 54 degrees. Therefore, DOC is equal to 2 times 54 degrees. 2 times 54 degrees, 108 degrees. So we got the two angles, required angles. BCT is equal to 54 degrees and DOC is equal to 2 times 54 degrees, and that is 108 degrees. Okay. Next, problem number 6, question 14 of exercise 18B. In the figure, chords AE and BC intersect each other at point D. Here we have AE and BC, they intersect each other at point D. Okay. If CDE is this angle, is 90 degree. AB is equal to 5 centimeter. Here we have AB. I am joining A and B, and AB is equal to 5 centimeter. BD is 4 centimeter. And CD is given. CD is 9 centimeter. Find DE. DE is this one. We have to find the length DE. Okay. So that is the first part. Here we have AB. AB is given. AB is 5 centimeter and BD is given. BD is equal to 4 centimeter. We need to find DE. In order to find DE, first let's find what AD is. Okay. How to find AD? Here, this is a right triangle. Why? Because if this angle is 90 degree, this will also be 90 degree. They are vertically opposite angles. AE and CB cross each other. Therefore, angle CDE and ADB are vertically opposite angles. This angle will be 90 degree. Angle ADB is equal to 90 degree. Vertically opposite angles. Okay. Now consider triangle ADB. In triangle ADB, here AB is the hypotenuse and let's take AD as the base. We have to find this base length AD. We have AD square plus BD square is equal to AB square. That is, we are applying the Pythagoras theorem here. Pythagoras theorem. Now put the values. We need to find AD square. AD square will be equal to AB square minus BD square. AB square. AB is 5. Therefore, 5 square minus BD. BD is 4. 4 square. AD square is equal to 5 square 25 minus 4 square is 16. AD square is equal to 9. 25 minus 16 we get 9. Then what is AD? AD will be equal to 3 centimeter. We got the length AD and AD is 3 centimeter. We need to find DE. Here when you consider these chords which cut each other at D, will be having AD into DE is equal to CD into DB. What is the reason? We have studied a theorem, you remember? When two chords intersect each other internally or externally, then the product of the length of the segments will be equal. So using this, we will be getting AD into DE is equal to CD into DB. What we need? We need DE. DE will be equal to CD into DB divided by AD. Now put the values. CD. CD is given in the question, which is 9 centimeter. DB. DB is this length. This is also given in the question, which is 4. And AD we have determined, which is 3. Okay, cancelling 3 and 9. 3 3s are 9. 3 into 4 will be getting 12. Okay, therefore DE, this length is equal to 12 centimeter. DE is equal to 12 centimeter. Now the second part. If AD is equal to BD, we have to show that AE is equal to BC. AE is this chord and BC is this chord. We have to say that both of these chords are of equal length. The given condition is AD is equal to BD. Okay, we have AD into DE is equal to CD into DB. What is the reason? We are applying the theorem here. Yes. When two chords intersect internally or externally, then the product of the length of their segments will be equal. Now, if AD is equal to BD, here we have AD and this is BD. If they are equal, then we will be having DE equal to CD. Yes, here we are taking AD is equal to BD as the first equation. If AD and BD are equal, then DE and CD should be equal. Okay, therefore DE is equal to CD. I am taking this as 2. Adding 1 and 2, what we get? AD plus DE is equal to BD plus CD. What is AD plus DE? AD is this one and DE is this one. When you add, you will be getting AE. AE is equal to, next, BD plus CD. BD is this part and CD is this part. Adding, we get BC. So this is what we had to prove. Hence proved. Okay. Hence proved that AE is equal to BC. Okay. Here we have the last problem for today. Problem number 7. Question 16 of exercise 18B. In the adjoining figure, O is the center of the circle and AB is the tangent to it at point B. Angle BDC is given, which is 65 degrees. We have to find BAO, this one. Okay, how to find BAO? First we'll be considering this triangle where angle is given. Consider triangle BCD. In triangle BCD, we know the measure. Angle BDC is equal to 65 degree. Then we have angle DBC. What is DBC? DBC will be equal to 90 degree. What is the reason? Here DBC is 90 degree. What is the reason? DB is the tangent. Okay. O is the center of circle. OB is the radius of circle. Okay. Therefore, the angle between radius and tangent will be equal to 90 degree. Clear? Angle between tangent and radius at the point of contact is 90 degrees. Okay. Therefore, we have DBC equal to 90 degree. Then what is the measure of this BCD? How to find BCD? Angle BDC plus angle DBC plus angle BCD is equal to 180 degree. The total angle will be equal to 180 degree. That is sum of interior angles of a triangle. Sum of interior angles of a triangle is 180 degrees. Okay. Now put the values. What is BDC? BDC is equal to 65 degrees. 65 degree plus. Then we have DBC. DBC equal to 90 degree plus BCD. BCD we have to find. Angle BCD is equal to 180 degrees. 65 plus 90, we get 155 degree plus angle BCD is equal to 180 degrees. Angle BCD is 180 degree minus 155 degrees. 180 minus 155, we get 25 degrees. Okay, so we got this part. This angle is 25 degree. Now, how does this angle help us find what BAE is? We have to find the angle BAO. That is same angle. That is BAE and BAO are the same angles. How does this angle help to find this? Using this, we can find the angle BOE. Okay. Now, if I am considering this arc BE, BE subtends angle BOE at the center of the circle and BCE on the circumference of circle. Therefore, we have angle BOE is equal to 2 times angle BCE. Okay, angle 2 times angle BCE. What is the reason? Angle subtended at the center is twice the angle subtended on the circumference of circle. Then what is BOE? Angle BOE will be equal to 2 times 25 degree and that is 50 degree. We got BOE is equal to 50 degree. BOE is 50 degree. Now when you consider triangle BAO. This triangle BAO. We have to find the angle BAO. Yes, we have to find angle BAO. What do we know? We know the measure of BOA, which we have determined. Angle BOA is equal to 50 degrees. What about this angle ABO? What is the measure of ABO? ABO we have, that is 90 degrees. Angle ABO is equal to 90 degrees. That is angle between the tangent and chord at the point of contact is always a right angle. Then we can easily find what BAO is. We have angle BOA plus angle ABO plus angle BAO is equal to 180 degrees. Now put the values. BOA is 50 degree. ABO is 90 plus BAO is equal to 180 degrees. 50 plus 90 we get 140 degree plus BAO is equal to 180 degree and BAO will be 180 degree minus 140 degree, that is equal to 40 degrees. Okay, we have determined the angle BAO which is 40 degrees. Clear? Understood? That's all for today. In today's class, we have discussed many theorems and problems from exercise 18B. There are a few more problems which are left, which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.